Okay, this is a question from June 10. This question is purely on trigonometry. Apparently, this looks to be a question on complex numbers, but this is to test your skills on trigonometry. Okay, so it says show that the modulus of z is this, and the argument of z is this. So this z is 1 plus cos 2 theta plus iota sine 2 theta. So you see when you have a complex number which is a plus iota b, that is your z, then the modulus is going to be the square root of a square plus b square. So the modulus of z is going to be square root of, acha, now instead of this 1 plus cos 2 theta, if you let me write, because 1 plus cos 2 theta is 2 cos square theta. So this will like help me to save a lot of space if I write instead of this 1 plus cos 2 theta, 2 cos square theta. So when I square this is going to be 4 cos raised to power 4 theta. Now sine 2 theta, what is sine 2 theta? That is 2 sine theta cos theta. So I square this, it's going to be 4 sine square theta cos square theta. Can I take 4 cos square theta common inside the square root? So you have cos square theta plus sine square theta, which is 1. So under root 4 cos square theta is going to be 2 cos theta. So you have proved this thing that the modulus of z is 2 cos theta, okay? Then it says prove that the argument of z is just theta, okay? So argument of z is going to be tan inverse of b, which is sine 2 theta over a, which is 1 plus cos 2 theta. So once again, you use both of these two identities here. So this is tan inverse of 2 sine theta cos theta over 2 cos square theta. So the 2's are cancelled, the cos theta is cancelled with this. So you have tan inverse of tan theta, which is theta. So, any question, Bacho? Hmm? Hmm?
Sir, can you explain the first part, uh, the modulus of z?
Whenever you have, like, look at this modulus of z is a plus iota b. So this is a square plus b square. So this is your a. This much is your a. It's square. So I have shown you that this can be written as 2 cos square theta. So when you square this will become 4 cos raised to power 4 theta. And then this was your b. And I have written this for me here that sine 2 theta is 2 sine theta cos theta. And when I square this, I get 4 sine square theta cos square theta. And I think the rest should be clear to you. Yes?
Okay, sir, thank you.
Okay. Okay, bacho, let's move on to the second part. So again, we test um, your knowledge, your skills on trigonometry. So it says prove that the real part, okay? The real part. So we have to be worried about the real part, okay? The real part of 1 over z. So 1 over z is basically 1 over 1 plus cos 2 theta. So I'll again write it as 2 cos square theta. And this is, I'll be writing this as iota 2 sine theta cos theta, because the lesser the number of terms you have, it's easier to handle them. So we have to show that this is its real part is constant, okay? So you see, I can take 1 over 2 cos theta common from the denominator. So I have 1 over cos theta plus iota sine theta. You know that whenever you have this complex number in the denominator, you have to realize this denominator. Okay. So this is going to be cos theta plus iota sine theta over cos theta plus iota sine theta. Okay. So you have here 1 over 2 cos theta into um, the denominator cos theta plus iota sine theta. Oh, I didn't change the signs here. No one told me. This should be minus. Should be minus. Okay. So a plus iota b. Remember, a plus iota b into a minus iota b is a square plus b square. So this gives me down here cos square theta plus sine square theta. Okay, and we are left with cos theta minus iota sine theta in the numerator. So you know that cos square theta plus sine square theta is 1. So we have 1 over 2 cos theta into cos theta minus iota sine theta. If I multiply this inside, so I have cos theta over 2 cos theta minus iota sine theta over 2 cos theta. This is half minus half iota tan theta. So what is the real part? If this is your 1 over z, so what is the real part of 1 over z? Yes, Bacho? What is the real part?
1 by 2.
That is 1 by 2, which is a constant. Yes, do you have any question?